Hello, and I'd like to welcome you to today's e-showcase, Plant Upgrade ROI, Improvements that Boost the Bottom Line. I would also like to thank ENGIE for sponsoring today's event. ENGIE North America has been helping customers for decades to transition to more efficient and environmentally friendly operations. And I'm going to go ahead and pass things over to Ravi and Aaron.
Good morning, everybody. My name is Ravi Bhaskar, and this presentation is going to be in two parts. The first is going to talk about general challenges facing wastewater professionals. The second part will be a specific project that was intended to ameliorate some of those challenges. I'll go ahead and start. I'm Ravi Bhaskar. I am Senior Wastewater Engineer, Water Wastewater Commercial Lead at ENGIE North America, and my counterpart is Aaron Weiner. He's the Director of Water Quality and Resource Recovery at West County Wastewater District. So the agenda basically this morning is common challenges facing professionals in the wastewater industry and opportunities for their resolution, process-based infrastructure upgrades, and finally, the West County Wastewater Project summary. So I'll go ahead and start with the first section, the common challenges. So many of you are associated with the wastewater industry. That's why you're members of WEF. But some of the challenges we have, and these are by no means comprehensive, is first of all, it's compliance requirements and unfunded mandates. You have nutrient limits that are being set for your effluent. Many plants are not set up to do nutrient removal. In some states, there are limits on phosphorus, for example, that are below the limit of detection of many analytical methodologies. You have increased organic loads, especially with the pandemic and more people staying at home, and also increasing concentrations with people using less water. And then you have restrictions on the disposal of biosolids. Landfill space is getting scarce. The workaround that many plants had of using sludge as a daily cover is no longer available, especially in California. And of course, there's rising costs. General energy costs rise at 3 to 4 times the rate of inflation. Rising chemical costs, as an example, just last year, the cost of chlorine as a disinfectant went up by a factor of 2 due to production shortages as a result of the pandemic. We talked about rising landfill tipping fees, rising organic loads, and of course, in many areas, disrupted weather patterns and increased storm events lead to rising inflow and infiltration and combined sewer overflow flows. So these are all challenges. Most plants were not set up or equipped to handle them. Again, that's only on the influence side. Inside of the plant itself, we have aging infrastructure. A lot of times equipment is set up to run to fail. So there's maintenance and repair that's deferred due to stretched capital budgets. And then you have, upgrade challenges. Nearly every wastewater plant in North America was built at a time when energy was cheap and controls were expensive. And as we all know, the situation right now is exactly the opposite. The other challenge is when plants are faced with the decision to upgrade a piece of equipment, they'll upgrade a bar screen or an influent pump, basically ad hoc or piecemeal upgrades without considering the whole plant, the effect on downstream process units. And then, of course, most wastewater plants in North America are publicly owned. They are subject to public procurement requirements, and that means that you have to do everything in the design, bid, build process. And by the time the process is done, the design itself is often obsolete because the regulations have changed and the compliance criteria have changed. So this leads to a situation where they further put off doing upgrades, and then that makes the situation even worse. And then, of course, there's the total cost of ownership. So um, what we at ENGIE like to do is to look at comprehensive, holistic views of the facility that consider long-term benefits, evaluate potential changes in the flow and load, whether you have pre-treatment programs, whether you have adequate planning for growth, whether you've considered population shifts and increase in usage as a result of the pandemic, especially when it comes to more people staying at home, a shift to occupancy to the suburbs away from downtown areas and office spaces. All of these have significant changes in the inflows and loads to the wastewater treatment facilities. And then, of course, one should consider all grants and incentives. Um, Many of us are wastewater professionals. We're preoccupied with the daily challenge of meeting our compliance limits. We don't know, for example, that the recently passed Inflation Reduction Act has incentives to produce biogas, or you can get up to 30% of the cost of a project with an investment tax credit. These are things that we're not aware of. We at ENGIE have a group that deals specifically with grant and incentive funding, and they mine the various government publications for opportunities to help our clients fund these projects. Another example is the self-generation incentive program, which pays utilities to generate their own power using biogas or solar or other renewable energy. Resilience can be worth up to 25% of the annual electric bill, whether it's via battery storage or microgrids, etc. So these are all things that are available to wastewater plants that many people are not aware of at this time. And then, of course, there's alternate revenue sources from operations of a wastewater plant. The biggest right now is the Federal Renewable Identification Number and the California Low Carbon Fuel Standard, LCFS credits. You can convert biogas to RNG, which is renewable natural gas, basically by removing the hydrogen sulfide and the carbon dioxide, converting it to pipeline quality gas, and injecting it into the pipeline. For plants that are large enough, you can have a $30 million project pay for itself in as low as 7 years. If you co-digest your sludge with high-strength food waste, you can often increase the production of gas by more than you would if you were to digest each stream separately. In many cases, you get revenue from tipping fees. And finally, if your biosolids are adequately stabilized and meet the federal criterion for Class A biosolids, then you can often, have a revenue stream for biosolids repackaged as fertilizer. In California, water is scarce, especially in the Central Valley. Tertiary treated effluent is often sold as reused water, sometimes getting as much as $200 an acre foot. An acre foot is 357,000 gallons. So there are revenue streams that are available even for small and medium-sized plants, but in many cases, the operators don't have adequate expertise or time to learn how to benefit from these opportunities and how to implement the projects that are needed to benefit from them. So I'm going to talk now about process-based infrastructure upgrades. And by that, what I mean is approaches for entire unit operations. So, for example, you can look at a thickening operation. It's just not just a matter of replacing a thickener. It's a matter of looking at what percent solids you're getting and what's the benefit from more thickening. Well, you get more solids residence time in the digester, which means that you produce more biogas, as an example. And the same is true for digestion, co-digestion, and of course, there may be unintended consequences. A lot of times people look at food waste without paying um, uh, adequate attention to the impact of a side stream. For example, you can have a high protein food waste stream that produces a lot of ammonia, which then impacts your aeration system. So it's essential to consider the entire unit operation or the entire plant when doing this kind of project. And it may call for alternate delivery methods. And the reason for that is if you just go with the traditional design, bid, build approach, the agency, the company that's doing the design for one unit operation may not have adequate expertise to look at other unit operations and look at the plant as a benefit as a whole. So this is where an integrated approach, this is where the agency benefits from an integrated approach. So looking at this slide, ENGIE North America has a range of wastewater facility upgrades. We do aeration systems, of course, because aeration is 55 to 75% of a plant's electrical energy load. We look at biogas production. We look at automation, as I said earlier. Many plants that are capable of being automated are not right now because the plants were designed at a time when the computational power was not available. Controls, SCADA, remote monitoring, which is a wonderful opportunity for operators to respond to alarms from the comfort of their homes. Look at revenue enhancement, high strength waste, fat, solids, and greases, recycled food waste. Look at biosolids handling, thermal drying, production of biosolids. We look at disinfection, and of course, we look at energy management for the whole plant as a whole. We look at outside generation, battery storage, and microgrid resiliency measures. So we offer comprehensive wastewater facility upgrades based on the unit operations that you have and the overall objectives that make sense for your agency and in your particular environment. A lot of times people say, well, what's the payback for doing something like this? And it's really not about payback. It's about where are you right now and where do you want to be in 20 years and what's the best way to get from here to there. As an example, right now we look at your baseline costs, your electric bills, your rate structure. Are you charging enough? Are you charging enough for your industrial users? Some places charge only 7 cents per pound of BOD. Other places charge 37 cents per pound. How does your rate structure fit in with your actual cost of treatment? What are your annual O&M costs? What are you doing for your biosolids disposal? And then in the middle are all the things that we've talked about earlier, everything that we help you upgrade if it makes sense. For example, aeration systems, biosolids, biogas production, demand reduction, etc. And on the right side, we have a financial model that specifies where you'd like to be in 20 years. What do you have in your existing capital budget that could be accelerated so that you start seeing the benefits right away? What's the total cost of ownership? That's your current cost plus your 20-year operating costs plus your energy costs. and how much can we impact those to reduce your overall total cost of ownership. And then finally, there's a triple bottom line approach. It's not just about economic benefits. It's also about social and environmental benefits. And so that is, all of those have to be considered. So again, to reiterate, it's not about where you are right now. It's where do you want to be in 20 years, and what's the best way to get there. So ENGIE has a comprehensive approach. It takes us, this is not a quick sale to a commercial, to a public agency. We spend time in the planning phase. We look at the infrastructure, your existing inventory. We look at technology options. We look at the financial picture. And of course, we make sure your stakeholders are engaged. The last thing we want to do is to create a perception that may affect your public relations later on. Then we go into the implementation phase, where we design, we build, we look at incentives. We look at your procurement, and there's regulations that allow agencies to use ENGIE as a source, but of course we have to go out to public bid for all of our contractors. We look at installation, and then finally we have the O&M portion of it. If we are willing to help you operate and maintain your facilities as well. Of course, we also have a community engagement where we offer scholarships and incentives to train students to enter the wastewater industry and to benefit to the benefit of the various agencies involved. So a little more about ENGIE. We're the #1 provider of clean energy in the world. And we have 170,000 employees. We have 48 years of experience in the United States, 175 years in Europe and across the world. Basically, we were formed by a merger between Gas de France and Suez. And Suez, as you might be aware, built the Suez Canal. So we have over 30 gigawatts of renewable energy capacity worldwide in 2020, and 21 million metric tons of CO2 removed from the atmosphere as a direct consequence of our activities. To reiterate, why should you partner with ENGIE? For all of the reasons that I outlined earlier, which is in-depth assessments, a turnkey solution, a single point of accountability. This is not something that's, especially when you have multiple contractors, multiple consulting firms and engineering firms working in your plant, and tripping over each other and pointing fingers. It's easier to have a single source of accountability, a single source of project management, achieve energy and operational savings, and of course, performance guarantees. In many areas, we guarantee that we will save you money, or we will write you a check for the difference between what we said we would save and what you actually save. And new revenue streams that I talked about earlier, from the production and generation of biogas, from additional revenue streams for renewable natural gas and biosolids and tipping fees and so on. So an example, a concrete example, is West County Wastewater. We saved them $83 million in the net program life over 20 years. We will be once we get to that point. We have renewable energy, 1.1 megawatts. We're putting in a 450 kilowatt cogeneration system powered by biogas. We will be generating Class A biosolids for agricultural uses, 4.2 million kilowatt hours of energy use reduction per year, and a 93% reduction in greenhouse gas over the life of the program. Most of that, of course, coming from they're not using their sludge drying beds that they had earlier and switching to alternative and environmentally friendly biosolids disposal practices. At this point, I'm going to turn it over to my colleague and friend, Aaron Weiner. Thanks.
Thanks for having us. Good morning and good afternoon for those on the East Coast or farther east. So a little bit about West County. We are located about 25 miles, actually about 15 miles east of Richmond. And if you see this slide in front of you, we are a special district whose mission is wastewater treatment, wastewater conveyance and treatment. And on the left-hand side of your slide there, you'll see the cities and neighborhoods or subdivisions that are part of our service area. There's a little bit better graphic about where we are on the next slide. West County Wastewater, you can see we serve about 34,000 residences and 900 commercial and industrial businesses, and our total population is about 100,000. Our sewer network is 250 miles of underground pipes, and in addition, 6 miles of force main. The first bullet there, the 250 miles, that's all gravity sewer. And here's a picture of our service area again, or a graphic of our service area. On the left, you can see the circle. And at the bottom of your screen, you see Oakland, or the bottom of that slide, you can see Oakland. To the left of Oakland, across the bay, is San Francisco. So that's where we are. And then on the right-hand side is a close-up, and it's a little bit hard to see, but if you look in the top left-hand of that slide on the right, it says West County Wastewater District. And there are several wastewater areas or agencies in this area, and ours is bounded by the solid black line towards near the top, in the top center of that slide. So the work that we do, we celebrated our 100-year anniversary last December. So obviously we've been doing this for 100 years. The water quality and resource recovery plant, we actually are a conventional activated sludge treatment plant. We do, however, have an advanced component to our activated sludge where we're producing very high quality water with suspended solids, typically less than 5 milligrams per liter, and turbidities down in the 1 to 2 or even less NTU range. And ammonia is less than 0.1 milligrams per liter in our effluent typically. For more than 20 years, we've had an agreement or various agreements with East Bay Municipal Utility District. They are a very large wastewater and water provider in the East Bay area, Oakland and the surrounding areas. So basically what we do is we provide our secondary effluent fully treated to them. East Bay Mud has 2 treatment facilities. They use our effluent, they reclaim it, polish it, and they send it to a local refinery. And basically what that does is it replaces what would need to be potable water used for these industrial uses. And as you can see on the bottom there, during dry weather, we average 7 to 7.5 million gallons a day through the plant. Our design is about 12 million gallons. And during dry weather, more than 90%, typically in the mid 90s during the summer, is taken by East Bay Mud and used for reclaim. So a little bit more about what we do. Mentioned the water quality and resource recovery plant, 17 sewer lift stations, and also you can see in the middle there, we contract, operate, and maintain two additional sewer lift stations and 1 storm pump station. And that work is done for Contra Costa County and also for the city of Richmond. which is a neighbor of ours. We're actually in the outskirts of the city of Richmond. We also operate a certified environmental lab and manage and implement a state-approved industrial pretreatment and pollution prevention program. And those are our environmental services folks. So challenges and motivation for this improvement initiative. So there have been changes to the regulations. They're always changing. They're always changing, as most folks in this industry know. And the California Senate Bill 1383 mandates the reduction of organic waste to landfills. And you can see there it's 75% reduction in 2 years from now, actually just about 3 years from now. And the methane produced by organics going to landfill are estimated to contribute 20% of the state's methane production. Then the next bullet there is the Bay Area Air Quality Management District Regulation 13, Rule 4. And you can see that the Air District is starting to look at municipal anaerobic digesters as it relates to methane production and emissions. To this point in time, methane emissions have not been regulated by the Air District from municipal wastewater treatment facilities, and that's changing. And then the bottom there, you can see that we have historically operated 70 acres of drying lagoons. And basically the digested sludge goes into those lagoons and it continues to emit methane uncontrolled and other desirable materials. And this project eliminates the need for the lagoons, and that property will be repurposed. In addition to the challenges noted in that slide, we're also replacing aged and unreliable and under-maintained wastewater infrastructure. And some of the new facilities that we're putting in here: digesters, gas cleaning system, methane flare, centrifuges for sludge dewatering, biosolids dryer, which will ultimately produce Class A biosolids. In addition, the electrical cogeneration system will drastically reduce historical emissions of digester gas, because historically we've used some of that gas for old equipment, old engine-driven blowers. It was never completely used, and what was not used was basically flared to the atmosphere. And those things are all changing. And then you can see here additional challenges and motivation, offset increasing utility and electrical prices. For folks who don't know, who don't live in California and aren't familiar, I'm sure you've heard about the wildfires that we unfortunately have typically this time of year. And what has happened is our utility provider has, which is Pacific Gas and Electric, has implemented public safety power shutdowns where they discontinue electric service to certain areas on a rotating basis when it's very windy and there are other conditions that contribute to high wildfire risks. And so one of the things this project is going to do for us is to improve our generation of clean electricity, and we will not be as impacted in the future by those public safety power shutdowns. And next slide is going to be, we're going to change gears a little bit in the near past and future of West County Wastewater, and some pictures coming up here. You can see on the right are two old digesters and an old gas storage tank on the lower right there, which have since been removed from service. Actually, they've been demolitioned, as you'll see in a minute. In early 2019, West County Wastewater issued a RFP for the ESCO services, and that's when we started talking to ENGIE. And just coincidentally, that coincided with about the time I started for West County Wastewater. So my 3 years here has coincided with the evolution of this project. And then you can see the rest of the timelines. I'm not going to go through all of those, but I guess it's worth noting that we broke ground. Actually, the next slide will show that we broke ground this past spring. And these are more of the timeline for this work. And then this shows you another, basically another aerial view of our treatment facility. And on the right are all of the additions and upgrades that we're doing as part of this, what we're calling our Clean and Green project. And as promised, here is the picture of the digester area that has been excavated and is being compacted for foundation and pilings for new digesters and the rest of the solids handling equipment that are coming as part of this project. And then this is basically a conceptual 3D snapshot of what the new facilities will look like. And you can see the new digesters in the middle in green, and then to the top, a little bit left of that is where the solids processing building is going to be, with gas cleaning, centrifuges, belt dryer, and then in between the digesters in that building is where the electrical cogen is going to be located. And I did want to mention that there's one other piece of this project that I don't think was captured anywhere in this slide. One of the things that we're doing is chemically enhanced primary treatment. And another word for it is carbon redirection. So we're basically installing polymer and I believe ferric chloride, which we're going to feed into our primary clarifiers to direct more BOD, biochemical oxygen demand, away from the secondary treatment system into the digesters, which will also enhance gas production in the digesters. And it'll also, just by the mechanics, reduce the load to the secondary system and reduce the need for, or reduce the aeration requirements, which will also save electricity. And then just a couple of overview aerial shots. The one on the left is 0.83, I'm sorry, it's 831 kilowatts of solar that we're installing as part of this project, which will help power the treatment facilities. And then on the right, you can see that our headquarters building, our headquarters offices, which is about 5 miles from the treatment plant, is also getting its own solar array, solar system, if you will. And we're also installing solar facilities, solar generating facilities at 3 of our largest lift stations. And then here's a summary of what the project is really doing for us. Our district has a strategic plan, and among the goals of the strategic plan are to adopt infrastructure maintenance and modernization strategies, be an environmental steward, and engage the community. And really, we're doing all of those things as part of this project. And it did mention in an earlier slide that our greenhouse gas reduction and our carbon footprint impacts will be reduced by an estimate. It's estimated at greater than 90% from what it is today. And that information is based on a greenhouse gas baseline study that we did, and also on the projected savings from this project. And that is the last slide. And from here, we're into questions and answers. Thank you very much.
Thank you so much, Aaron and Ravi, for a great presentation. I will invite all attendees to go ahead and put your questions into the chat box now. You can select either everyone for attendees and the panelists to see, or you can also just select all panelists. I do have a few questions that have come in previously, Aaron and Ravi, so I'll go ahead and get started on those while we wait for the other ones to come in. So I will go ahead and ask, I guess the first question is how do I get started? Where, to invest in something like this? If Ravi or Aaron, you can please answer that.
Would you like to take that one, Ravi?
Sure. Tell us where your facility is located, about what your annual energy consumption is, and some basic flow information, and we'll send someone to take a look at it. My email address is in the webinar invitation and can be obtained from the chat box as well.
Thank you so much. I did just place both of your email addresses in the chat for everyone to see. I will go ahead and go to the next question as well. I have a question from Jennifer here that says, can you say again what you have solar-wise on the lift stations?
Yeah, so three of our largest lift stations we're installing solar power generating for those larger lift stations. I can't quote the size of the solar installations, but they're large enough, I believe, to supplement or to provide most of the electrical for those pump stations. Does that answer the question?
Yes, thank you, Aaron. And next we have, what's the previous and projected, I don't know these, KWH, and what's the total WWTP project cost?
So I can answer that. They already had, the plant load is about 2 megawatts. They already have about a megawatt of solar on place. We are generating 450 kilowatts from the cogeneration system and making up the rest of it with additional solar. So basically it will be a net zero wastewater plant. The total cost of the project is around $65 million. Project pays for itself through energy savings and through operational savings by reduced biosolids disposal costs, about $2 million a year, and generates about $83 million in savings over the contract period of 20 years.
Great, thank you. And then I have another question from Shelley coming in. It says, you mentioned revenue from Class A biosolids. Are you partnering with a fertilizer company, or is the municipality distributing or selling biosolids?
So go ahead.
Go ahead, Ravi. I'll piggyback if you want to start.
Sure. Some municipalities offer biosolids packaged directly to the public. For example, Kent County in Delaware offers Kent Organite, which is basically packaged Class A biosolids that have been stabilized, dried, and pelletized. West County has their own arrangements, which I'll let Aaron talk about.
Thanks, Ravi. And yes, we are looking to, if you will, commoditize our Class A biosolids, and we do have we will not be doing so directly. It's likely that we will be using a middle person, and we actually use Synagro. Folks probably have heard of Synagro. I think they're a national company, and they're managing our solids disposal at this point. And since we're about 2 years out, we haven't really finalized details, but I expect that we will continue to work with them, and you know, and I think they would be the group that does the sale, you know, the sale of the biosolids.
Great, thank you. And Aaron, I think this is directed to you, but I might be mistaken, or both of you can address it. But what are the biggest challenges faced with the project to date?
Well, yeah. So the biggest challenge, you know, in any project of this complexity is really communications, and you know, really from the start 3 years ago. Just because there are so many players involved, there are so many moving parts, that's always just a huge challenge. From an operational perspective, what we were up against, what we were facing as a utility, as a wastewater utility, in terms of equipment and infrastructure failures, really challenged us to it challenged us to come up with a time frame to really be able to, excuse me. The challenge was coming up with a time frame to do all the work we needed to do. And so this project has allowed us to meet that challenge, because we were able to wrap in, for example, new digesters, which weren't conceived in the initial discussions and in the initial talks about the project. So we were able to basically take items that otherwise would have been on our master plan out years and roll them in here. So that was a challenge that was met by this project. And the other thing is, we are a relatively small agency. We have 65 positions, I believe, with 75 altogether. 65 are filled. And we didn't have the capacity to oversee a project this large. So we basically had to hire several engineering consulting firms to assist us to oversee the work. So I think really that's the biggest challenges that we've had. Those are the biggest challenges.
One other that I would like to highlight is that, and this is probably true of nearly all wastewater plants, is when you're upgrading critical infrastructure, you have to keep the plant running. And so in many cases, that involves duplicating a unit operation, such as aeration or thickening temporarily while the new equipment is installed. And that requires a significant amount of coordination with the plant staff in order to keep things running and not breach compliance while we're doing it. So that, to me, is a challenge with any large wastewater project, but it was especially the case with this one.
Yeah, that's a great point, Robbie. And if you just look at the sheer number of, including ENGIE and West County Wastewater District, and if you just look at the number of contractors, the number of consultants, plant staff, as Ravi mentioned, I mean, that really boils back to the communications piece. But yeah, keeping all the information going where it needs to go, and again, in our case, being a special district, this whole thing had to be approved by our board of directors. So, just endless complexities. I guess I'll just leave it there.
Sounds great. Thank you so much to both of you. I will, we are just about out of time, so I do want to hand things back to both Aaron and Ravi for closing comments, if you have anything additional to say before we close out today's e-showcase.
I'll go ahead and start if you don't mind, Ravi. Yeah, just wanted to thank the Water Environment Federation for having us here, and also all the attendees. And I think just to encourage, you have contact information. So if you've got questions, I'm happy to answer questions, and look forward to hearing from folks if there's any way I can help or we can help. Thanks.
Yes, I'd like to echo what Aaron said. Thanks especially to the Water Environment Federation and Joy Lukasevich for helping us set this up. And again, feel free to contact me if I can answer any questions or be of any other assistance.
Yeah, thanks, Ravi. And I'm sorry, there was one other. I don't think I thanked you, Ravi, and ENGIE, because obviously, we've got a great partnership, and just wanted to do that before we close. Thanks.
Yeah, feelings mutual, Aaron. Thanks.